So the next area that you're going to want to think about, particularly as your database size grows, is what kind of maintenance is necessary to keep your database up to date. Now, I'm not talking about maintenance here per se, but Postgres, for example, has a process it calls vacuum. So how Postgres handles its concurrency control is it uses something called multi-version concurrency control. So what that means is it keeps multiple rows of data as it incorporates changes or deletions so that other people who are using the database system can potentially get a different version, a different view of that data. So for example, when I go and I update a row and I update in a column, say A to B, it actually retains the old row for as long as that version needs to be around based upon who else is connected. Then vacuum comes around and essentially vacuums up or deletes that row so it doesn't exist anymore. So that's the main purpose of vacuum, but vacuum also does other things to help keep your database optimized. So it also does things like update a visibility map, which can be important for certain types of indexes to work efficiently, as well as gen index performance that you were talking about before, which is typically an index you put on JSONB, or if you're doing full text search on text columns, that becomes very important, the frequent vacuuming for that. So basically you want to take a look at your Postgres tables to make sure that they are vacuumed on a regular basis and that you have auto vacuum running. Now it runs by default. And again, if your database is small, you probably don't need to worry too much about this, but as your data size grows, that becomes more important, is vacuuming frequently enough. The other thing that also vacuum handles typically when it runs is doing an analyze. And what that analyze does, it's a separate process, but it works within vacuum, is it analyzes all of your data to collect statistics. So how Postgres works, or the planner works, when you give it a query, the planner looks at what you're asking for, looks at the structure of your table or tables, the indexes that are available, as well as statistics about what values exist within each column. So for example, the statistics of a column that just has, say, 3 values in it will be very different than an unique ID column that has all sorts of different unique values. So those statistics are stored and they need to be kept up to date so the Postgres planner can understand how to best structure the query to give you the data you need.
And the planner, you're saying planner, just quickly. So you're talking about the thing that decides which indexes should I use, which order should I execute these bits in, that kind of stuff.
Right. Again, because you're just saying select all these orders after this particular date and join it to the warehouses that exist in the US, all your query that you're asking for that information, it's the planner that actually does the intelligence of, okay, I'm going to choose to use this index and this index in this table and do this type of join on them and then do a filter by this. So it's the planner essentially doing the coding for you. Mm-hmm. So someone's developed, you can call it an AI if you want, circa 1980. So it's basically deciding the query that you give it, how am I actually going to execute it? So that's what the planner is. So it needs this statistical information to make the best plan to pull out your data efficiently. So like vacuum, you're going to want to make sure that you're analyzing frequently enough so that your statistics are up to date. If you like this clip and want to watch another one, you can click right here. Or if you want to watch the full video, you can click here.